Welcome viewers, in this video we'll see the details about the Millman's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Millman's theorem, one of the theorem available in the circuit theory. So this theorem enables a number of voltage or current sources to be replaced by single voltage source or single current source. So the main objective of the Millman's theorem is with n number of voltage or current sources can be replaced by a single voltage source or single current source. Now we'll see the statement first for the voltage source by referring the voltage source. Then we'll go to the current source. In any network, if the voltages V1, V2 up to Vn with internal impedance Z1, Z2 up to Zn respectively are in parallel, then these sources may be replaced by a single voltage source with V in series with the impedance Z. Refer this diagram. So we have voltage sources V1, V2, Vn, right? N number of voltage sources available. In each source we have the impedance Z1, Z2 up to Zn, right? So the voltage sources are connected in parallel that can be replaced by a single voltage source with a single impedance V. Is a single voltage source V with a single impedance Z. This is a terminal AB. Terminal AB we have n number of voltage source connected in series with the impedance that is replaced by single voltage source and impedance. Now we see how to calculate this, the value of V and Z, voltage and impedance. So the voltage V is nothing but V1 into Y1, right? So this Z1 is available, impedance. Y1 is nothing but admittance. 1 divided by Z1 is nothing but the admittance. So V1 into Y1 plus V2 Y2 plus up to Vn Yn divided by the sum of admittance Y1 plus Y2 up to Yn. So by using this formula we can calculate the voltage, resultant voltage V. Similarly the impedance Z equal to 1 divided by Y1 Y2 up to Yn, right? So the n number of voltage sources connected in parallel replaced by single voltage source with impedance. The single voltage source V is calculated from this formula. Impedance is calculated from this formula. Y is nothing but admittance. So in general we can write it as V equal to sum of V into Y divided by sum of Y. Voltage into admittance divided by sum of admittance. The Z is nothing but 1 divided by sum of admittance. So in the given circuit converting each voltage source into equivalent current source. Now we'll see the proof for that, how we are getting this formula. So this first we'll consider the voltage source, that is now we are going to convert into current source. Now we'll see the diagram, how we are converting from voltage source to current source. Now refer this diagram, we have the current source available in parallel with impedance is connected. This is the first current source, second current source and third current source. Now that is converted into current source in series with parallel with the admittance Y1, I1, Y1. Similarly I2, Y2, I3, Y3, right? So the current source now converted into the current source with the admittance. Now we'll see the formula for that. I1 equal to V1 by Z1. So this 1 divided by Z1 is nothing but Y1. Admittance and impedance both are reciprocal, right? Impedance means opposing the current, property opposing the current. Admittance means allowing the current. So that 1 divided by Z1 is Y1. Similarly I2 equal to V2 by Z2, that is V2 into Y2, admittance. Similarly I3 equal to V3 by Z3, that is equal to V3 into Y3. Right? So this Y1 is nothing but 1 divided by Z1. Y2 is 1 divided by Z2. Y3 is 1 divided by Z3. Right? So this circuit refers impedance. This circuit refers the admittance. Current source in parallel with the impedance. Here current source in parallel with the admittance. Now we'll go for the further analysis. So now the current source are in parallel we can obtain single current source. Single current source equivalent to the combination. Let I be the current and Y be the admittance of the equivalent current source. So that I equal to I1 plus I2 plus I3. So the admittance Y equal to Y1 plus Y2 plus Y3. So by using that we can draw this diagram. Only one current source in parallel with the admittance. How to calculate this V? V equal to I by Y. That is I by Y1 plus Y2 plus Y3. I also I1 plus I2 plus I3. Right? So that V equal to I by Y, that is sum of currents divided by sum of impedance. Right? So this one can be converted into voltage source also. The same thing can be converted into voltage. Converting the above into equivalent voltage source. Voltage source means impedance is connected in series with the voltage source. Current source means connected in parallel. Voltage source means current connected in series. So we have V and Z. How will you calculate this Z? V is already calculated. V equal to I by Y. So this is the formula. Right? I1, I2, I3 divided. This I1 is nothing but V1, Y1, V2, Y2. So V can be calculated. How to calculate Z is 1 by Y. That is 1 divided by Y1 plus Y2 plus Y3. Right? So current source with admittance available. By using that we can convert voltage source into impedance. The voltage is calculated in terms of the sum of voltage and admittance divided by sum of admittance. This impedance is calculated 1 divided by sum of admittance. This admittance value available here. Now we'll go to the current source. This is depends upon the voltage source. Now we'll go to current source. Now consider this current sources. There are 3 current sources connected in series with 3 impedance. Consider 3 current sources of I1, I2 and I3 having internal impedance of Z1, Z2, Z3 connected in series. Our aim is to replace by a single current source, single source. These 3 current sources with internal impedance can be replaced by a single source. That is our aim. So the step 1 is convert each current source into equivalent voltage source. Into equivalent voltage source. So V1 is connected in series with the Z1. Current source means it is connected in parallel. Voltage source means it is connected in series. V1 Z1, V2 Z2, V3 Z3. This terminal A and B. Right? Now the current source, 3 current source with internal impedance are converted into voltage source with internal impedance. These are all connected in series. Current source means it is connected in parallel. Since all 3 voltage sources are series, replace them by a single voltage source and single impedance Z. How to calculate? V equal to V1 plus V2 plus V3. All are connected in series. Similarly, impedance also connected in series. Z equal to Z1 plus Z2 plus Z3. So that we can replace with a single voltage source and single impedance V and Z. Right. Now we'll see the equivalent current source. Again, how to convert into equivalent current source. So this is the current source is available, I and Z. Right? How to calculate I, V by Z? V is nothing but V1 plus V2 plus V3. Z is nothing but Z1 plus Z2 plus Z3. That just now we calculated. So I equal to this again. V1 is nothing but I1 into Z1. I2 Z2. I3 Z3. So that Z1 Z2 Z3. Right. So from that, how will you calculate Y? The admittance is 1 by Z. Is 1 divided by Z1 plus Z2 plus Z3. So now this current source with impedance is replaced by current source with admittance I and Y equal to 1 by Z. Right. So this I is calculated by using the formula. This Y is calculated by using this formula. So in this video we discuss about the Millman's theorem. Converting n number of current source or voltage source into single current source or voltage source. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the solved problem based on the Millman's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Calculate the current I in 4 ohm resistor in the network shown below using the Millman's theorem. So the network is given. there are two voltage sources available, 12 voltage and 20 voltage. The two resistors available, 3 ohm and 5 ohm, and one more resistor, 4 ohm. The question is, you have to find the current flowing through this 4 ohm resistor. It is termed as the terminal AB. So the Millman's theorem is nothing but the n number of current sources or n number of voltage sources are converted into single voltage source and single impedance. That is the main objective of the Millman theorem. N number of voltage source or n number of current source with internal resistance or impedance is converted into single current source or single voltage source with a single impedance. So here we have two voltage sources available. So the step one is we will convert these two voltage sources into single equivalent single voltage source. That is the first step. Similarly, there are two resistors available. Then we need to find the single resistance, equivalent single resistance. So the step one will go to the step one. In the given circuit, the two voltage sources are in parallel between the terminal A and B. One voltage source is connected one end of the terminal AB, another voltage source connected another end of terminal AB, so that it is parallel. So this circuit can be drawn as below. So this is the circuit is redrawn. So this is one voltage source with internal impedance 3 ohm. This is another voltage source with internal impedance 5 ohm. This is the terminal AB. In that we have the resistor R. Now we need to find the current I. Right? So the voltage source available this side is now transferred to that side. Now both the voltage sources are drawn in a same side. So we can convert this voltage source with a series impedance, series resistance. Another voltage source with series impedance can be converted into single voltage source and single resistance. So after converting this circuit become very simplified. We are having only one voltage source, one resistor and one load resistor. These are all connected in series. So we can easily calculate the current. I equal to V divided by R, sum of these two current. So that we are converting the two voltage sources into single voltage source with a resistance. Then how will you calculate this voltage and resistance? That is the second step. We need to find this voltage V and resistor R. See these two voltages are parallel. These two resistor also parallel. So there is a formula is available to calculate the equivalent voltage and equivalent resistance. Now we will see how to calculate. We will see how to calculate the equivalent voltage and resistance. So this parallel combination can be replaced by a single source of voltage V and internal resistance R. Then how will you calculate V? V equal to V1 Y1 plus V2 Y2 divided by Y1 plus Y2. So this is a formula available in the Millman's theorem. This Y is nothing but admittance. That is nothing but 1 divided by R1. Both are reciprocal. Resistance means opposing, admittance means allowing. So Y1 is nothing but 1 divided by R1. So that V1 into 1 divided by R1 plus V2 into 1 divided by R2 divided by 1 divided by R1 plus 1 divided by R2. Now all the values are available. V1, V2, R1, R2. The first voltage source is second voltage source. So that V1 is 12, V2 is 20, R1 is 3 ohm, R2 is 5 ohm. That is available in the diagram. Similarly, R1 is 3, R2 is 5. Right? So we need to simplify this. 12 divided by 3, 4. 20 divided by 5 also 4. Divided by, while taking LCM, we got 8 divided by 15. Right? So 4 plus 4, 8. 8 divided by 8 divided by 15. So 8 cancel. 1 divided by 15 will come to the numerator. So 15 voltage. So after simplifying, we got a single voltage source of 15 voltage. Right? Now we will calculate the resistance. R equal to Y, that is 1 divided by Y1 plus Y2. I already told these both are reciprocal, resistance and impedance. So that we need to find 1 divided by Y1 plus 1 divided by Y1 plus Y2. Y1 is nothing but 1 divided by R1 plus 1 divided by R2. Right? R1 value is 3, R2 value is 5. Right? So while taking LCM, it is 8 by 15. While going numerator, it become 15 by 8. That is 1.875 ohm. Right? Now we calculated the single voltage source as 15 voltage, single resistance 1.875 ohm. So from this we can easily calculate the current flowing through the 4 ohm resistor. That is by Ohm's law, I equal to V by R. I equal to V by R. V is 15 voltage, what we calculated, divided by R plus 4. Right? R value what we calculated 1.875. This 4 is the load resistance. Right? This is the question. The current flowing through 4 ohm resistor. So after simplified diagram, we have only one voltage source and only one resistance and one load resistance. These two are connected in series, though it is added together. Both are added together. So 15 divided by 1.875 plus 4. That is 15 divided by 5.875. That is equal to 2.553 amperes. So current flowing through the 4 ohm resistor is 2.553 amperes. So in this problem, we calculated the current flowing through the 4 ohm resistor. It is marked as the terminal AB. In the given circuit, the two voltage sources with the two internal resistance available. So the Millman's theorem means the n number of voltage source or current source is converted into single voltage source or single current source. By using that, these two voltage sources converted into single voltage source with a single impedance. After that, the circuit is simplified. From the simplified circuit, we easily calculated the current flowing through the 4 ohm resistor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the solved problem based on the Millman's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, solved problem in Millman's theorem. Use Millman's theorem to determine the voltage across 50 ohm resistor in the network shown below. So this is the network is given. We need to find the current flowing through this 50 voltage across this 50 ohm resistor. Right? So here one voltage source is available, 60 voltage. Here another voltage source is available, 100 voltage. And 3 resistors, 20 ohm, 10 ohm and 30 ohm. So the Millman theorem means nothing but n number of current source or voltage source with the internal resistance are converted into single voltage source or single current source with the single impedance. That is the main objective of the Millman's theorem. So here also we can convert this. So two voltage sources can be converted into single voltage source. But in this problem we are going to use the formula. A formula is available. After converting, the resultant formula is available. By using the formula, we can find the voltage drop across the 50 ohm resistor. Right? So the step 1, first we'll follow the step 1. Step 1 is nothing but the given network is redrawn below. Let the terminal 50 ohm be 0 dash as shown in the diagram. So this terminal 50 we marked as 0 dash. Right? This only we need to find the, here only we need to find the voltage drop. Voltage drop across 50 ohm resistor is marked as 0 dash. And this terminal is marked as 1, 2 and 3. So the terminal 1 is connected with 60 ohm resistor, 60 voltage source and 20 ohm. Terminal 2 is connected with 10 ohm and 100 voltage source. Terminal 3 is connected with, there is no voltage source but 50 ohm is available. No need to consider this 30 ohm, right? So we consider these 3 terminal, 1, 2, 3. In terminal 1, the voltage source is 60, internal resistance is 20. In terminal 2, voltage source is 100, internal resistance 10. In terminal 3, voltage source is 0, internal resistance 50. So by using that, we can, if we consider this, we can use the formula directly. We can use the Millman's formula directly, right? 60 ohm, 60 voltage, 20 ohm. And 10 ohm, 100 voltage. 0 voltage, 50 ohm, right? So this is nothing but V01, V02, V03 is 0. So this is R1, R2, R3, right? So by using that, we can go for the second step. So the step 2, 20 ohm, 10 ohm, 50 ohm are connected to the common point O dash. let the other terminals of the resistor is marked as 1, 2, 3. Right? 1, 2, 3. All these resistors are connected to the terminal O dash. Right? So we'll refer the diagram again so that it is easier. So this 20 ohm connected in point 1, another end is connected to O dash. 10 ohm connected to point 2, another end is connected to O dash. This 50 ohm connected to point 3 and another end is connected to O dash. Right? So based on that we can write the formula as V01 is 60 voltage, V02 is 100 voltage, minus 100. It is connected in reverse order. See this, here plus minus, here minus plus. So that we have to take it as minus 100. Then V3, the voltage source is not available, 0. Y1 is 1 divided by R1, 20 ohm, 1 divided by 20. Y2 is 1 divided by R2, 1 divided by 10. Y3 is 1 divided by R3, 1 divided by 50. Here only we are going to find the voltage, right? So this is R1, R2, R3, 1 divided by R1, 1 divided by R2, 1 divided by R3. Now the 3 voltage sources with 3 impedance available, that can be converted into single voltage source. We are not converting into single voltage source, directly we are going to find the voltage. So VOO dash equal to V01 Y1 plus V02 Y2 plus V03 Y3 divided by Y1 plus Y2 plus Y3. So this is a formula available in the Millman's theorem, right? This Y1 is nothing but the admittance, that is 1 divided by resistance. Y1 equal to 1 divided by R1. So V01 is 60, Y1 is 1 by R1, 1 by 20, minus 100, V02 is minus 100, R2 is 10. So Y2 is 1 by R2, 1 by 10, plus V03, voltage source not available, 0. Y3 is 1 by R3, R3 is 50 voltage, divided by 1 divided by 20 plus 1 divided by 10 plus 1 divided by 50, R1, R2, R3. So this term is totally 0, right? 60 divided by 20, 3. 100 divided by 10 is 10, right? Here we are taking 100 as a LCM, so that 5 plus 10 plus 2. Here 5 times going, here 10 times going, here 2 times going. So 3 minus 10 is minus 7. This is 17 by 100. So minus 7 into 100 by 17. After simplification we got minus 41.2 voltage. So the voltage drop across 50 ohm resistor is we marked as 0, 0 dash, it is minus 41.2 voltage. So in this problem we use the Millman's theorem. From that we calculated voltage across the drop across the 50 ohm resistor, that is marked as 0, 0 dash. Millman's theorem means convert the n number of voltage source into single voltage source with the impedance. Here already the voltage sources are available. We marked as 3 terminals, 1, 2, 3, with 3 voltage source and impedance already connected. The third voltage source is 0. Other 2 voltage sources are available. But by marking all these 3, we can use this formula directly. So this is the formula, resultant formula by the Millman's theorem. By using the formula, we calculated the voltage drop across 50 ohm resistor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.